Okay, we're going to jump into the first free response question for today, which is, you can see, is from the 2006 Form B test, problem number 2. So you should have gone through and tried your best to answer this in its completion, and you're just using this video to check your work and fix anything that you might have gotten incorrect. So let's read through the question. A large company has two shifts, a day shift and a night shift. Parts produced by the two shifts must meet the same specifications. The manager of the company believes that there is a difference in the proportion of parts produced within specifications by the two shifts. To investigate this belief, random samples of parts that were produced on each of these shifts were selected. For the day shift, 188 out of its 200 selected parts met specifications. For the night shift, 180 out of its 200 selected parts met specifications. Part A is asking us to use a 96% confidence interval to estimate the difference in the proportion of parts produced within specifications by the two shifts. All right, so let's scroll down. You can see our work for this. So anytime we're doing a confidence interval, as I'm going through this, I'm going to go tell you exactly what the AP test is going to be, the AP graders are going to be looking for. So make sure you're making notes. We might be adding a few little things to these problems. So again, just make sure you're taking really good notes so you're including all these components in your answer. So the first thing you want to do when you're making a confidence interval is write down what type of confidence interval it is. So as you see, I've written down a 2-sample Z confidence interval because it's 2 samples, and it's a proportion, which means it's going to be using a critical Z score instead of a critical T score. So a 2-sample T confidence interval. The next thing I want to do is check my conditions. So we're going to do the conditions slightly different now because we're gearing them towards specifically the AP test. So we're only going to do 2 conditions now. We're not going to do the 10% condition just because for some reason they don't check that one on the AP test. So we're just going to do the random and the normal. And something that we're going to add to the random is we're going to use the word independent random samples. That essentially means that each individual is not going to affect the other. So, yeah, just use that word independent when you're including it in your random sample from now on. So our conditions, the random conditions met because independent random samples from 2 separate populations are selected. So that condition is met. Then for our normal condition, we have to do the n times p hat and n times p hat, or 1 minus p hat. And remember, both of those need to be greater than or equal to 10. And since we have 2 different samples right here, there we go. 2 samples right here and right here. We're going to have 4 different calculations total for that. All right, and as you can see, all those are greater than or equal to 10. The closest one to 10 was this one right here. Came out to 12, but still greater than 10, so all those check out. So we know that our samples came from independent random samples, and then also, because this condition was met for number 2, we know that the sampling distributions will be approximately normally distributed. All right, and then also you want to make sure that you're defining your parameters. So what P1 represents and what P2 represents. So P1 is going to be the proportion of parts from your day shift, and P2 is going to be your proportion of parts from your night shift. So then we just plug it into our formula. We take sample number 1 proportion minus sample number 2 proportion plus or minus our critical Z-score. So again, the way that we get that, we have a 96% confidence interval So that means that we have 2% left in the tails. So you're going to put 0.02 in for the area on inverse norm. Since we're doing a z-score confidence interval, we're going to use the critical z-score, which is going to be inverse norm on your calculator. And that comes out to 2.054. Remember, for these critical scores, we want to include 3 decimal places. Then for the standard deviation, or the standard error, because remember the standard deviation is also called the standard error in a confidence interval, we take p hat, which is 0.94, times 1 minus p hat, which is 0.06, divide that by the sample size from sample number 1. Then we add it to p hat from sample number 2, which is 0.9, times 1 minus p hat from sample number 2, which is 0.1. Divide that by 200. Add those together and we take the square root, which comes out to 0.0271. So that all together, just that 0.0271, remember that's our standard error. We call that our standard error. And then when we go through and multiply it by our critical z-score right here, that gives us our margin of error. So then the 0.04 is our point estimate, and the 0.0557 is our margin of error. And when we add and subtract that from the point estimate, our confidence interval comes out to negative 0.0157 to 0.0957. So then the third part of our confidence interval is we want to make sure that we are right in our interpretation. So we say, based on these samples, we can be 96% confident that the difference in the proportion of parts, meaning specifications for the 2 shifts, is between negative 0.0156 and 0.0956. So again, want to have a short, concise, clear, and contextual sentence as part of our interpretation. So let's go to the scoring on this first part. So as you can see, you would either get E, essentially correct, or incorrect. There's no partial credit for these different parts. So as long as you correctly identified the correct confidence interval and identified your conditions correctly, explained them, you would get an E, essentially correct. If you're missing one of those parts, then you would not get essentially correct. So again, this is why it's really important that you're really including every single part of these problems, because if you just calculated the confidence interval, you would have gotten an I on that first part. So make sure that you are including all these parts as you're calculating. Then the second part is coming up with the correct calculation for your confidence interval. So as long as you calculated that correct with the correct work, you have gotten essentially correct. And then the last part is for the interpretation. So if you had all the interpretation right, you have gotten essentially correct for that. So let's move on now to part B for this. This is based on this confidence interval. Do you think that the difference in the proportion of parts produced within specifications by the 2 shifts is significantly different from 0? And our response is, since 0 is in the 96% confidence interval, 0 is a plausible value for the difference of P1 minus P2, and we do not have evidence to support the manager's belief. In other words, there does not appear to be a statistically significant difference between the proportion of parts meeting specifications for the 2 shifts at a significance level of 0.04. So remember, we can use a constant interval to come up with our a conclusion based off a test. So a 96% confidence interval is going to correspond to a significance level of 0.04. A 90% confidence interval is going to correspond to a significance level of 0.10. 99% confidence interval would correspond to a significance level of 0.01. So we can come up with that conclusion. So in this case, with this problem, we don't have statistically significant evidence because we look back up at our confidence interval, 0 is included in it. So if it's included, we think that that could be a possibility. So we don't say that we have evidence to say that it's not 0. So the scoring thing got cut off on this, but essentially, if you had a good interpretation, you would have gotten E. If you didn't, you would have gotten I for that. So the way that the scoring is set up on this problem is your final score would have been out of 4. So if you've gotten, let's see, if you have gotten all 4 essentially correct, you would have gotten 4 out of 4. If you have gotten 3 out of those 4 parts correct, essentially correct, you have gotten 3 out of 4, and so on and so on. So again, really important that you're including all these different parts. So I really take the time to study this video, make sure that you have all those parts down memorized, so when you take your summative next class that you have all those parts included and can get full credit.